So here's what we're really asking when we search for intelligent life. We're asking how many worlds have cleared every single one of these catastrophically unlikely hurdles: origin of life, complex cells, multicellularity, intelligence. And then, because intelligence alone isn't enough, technology, the capacity and motivation to build tools, to understand physics, to reach out across the void with signals we could recognize. When you multiply all those probabilities together, even generous estimates, the numbers collapse. They don't just get small, they approach 0 or 1, meaning we might be it. The single instance. The only time and place in the observable universe where all the accidents aligned in the right order. But let's keep pushing. Let's say we're wrong about the filters. Let's say life is common. Complex life is reasonably frequent. Intelligence arises now and then. Even so, there's another problem that makes detection nearly impossible: timing. The galaxy is 13 billion years old. Our sun is younger, 4.5 billion. Which means there were billions of years, billions before Earth even existed, during which stars were forming, planets were coalescing, and potentially life was arising elsewhere. Other worlds could have gotten started long before us. Civilizations could have risen, flourished, and vanished billions of years ago, leaving no trace we could detect from here. Or they could arise millions of years from now, on worlds that haven't formed yet, around stars still condensing from nebulae. The window of time during which two civilizations might overlap, might exist simultaneously, might both be broadcasting, might both be listening, could be vanishingly narrow compared to cosmic timescales. A few thousand years, maybe, a few centuries. The blink of an eye, in geological terms, invisible in astronomical terms. We've been capable of radio transmission for about 100 years, 100 years out of 13 billion. And already we're moving toward technologies that don't leak signal into space the way early radio and television did. Fiber optics, directed communication, encryption that makes transmissions look like noise. If we go quiet, not extinct, just technologically sophisticated enough to stop accidentally broadcasting, we become invisible to anyone searching the way we're searching. How long is the loud phase of a technological civilization? Maybe a century, maybe two. And during that brief window, your signals expand outward at the speed of light, forming a growing bubble of detectability. But that bubble is tiny compared to the galaxy. After 100 years of broadcasting, you're detectable out to 100 light years. That's a trivial volume, a speck. Most stars in the galaxy are thousands of light years away. Most are too far to have heard us yet, even if they're listening. And here's the cruel symmetry. If there's a civilization 1,000 light years away that went through their own loud phase 1,000 years ago, we're only receiving their signals now. And by the time we could respond, another 1,000 years will have passed. They might be gone, extinct, transcended, or simply moved beyond the technology that produced the signals we finally detected. We're all ships passing in a night so long that no two ships ever see each other's lights. The universe isn't just vast in space, it's vast in time. And synchronizing across both dimensions simultaneously is a coordination problem of impossible difficulty. Even if there have been 1 million civilizations in the Milky Way's history, and that's wildly optimistic if they're spread across billions of years and only detectable for decades or centuries each, the odds that any two overlap in a way that allows communication are crushingly small. This is another answer to Fermi's question. They're not silent, they're just not here now. Or, they were here, but we weren't. Or, they will be here, but we won't be. The universe is full of missed connections, conversations that never happen because the participants exist at different times, speaking into darkness, never overlapping. Now, let me introduce an idea that makes all of this even stranger. Maybe advanced civilizations don't stay detectable because they don't stay recognizable. Think about our own technological trajectory. 100 years ago, we couldn't fly. 50 years ago, we landed on the moon. 20 years ago, the internet was still novel. Today, we're developing artificial intelligence, gene editing, quantum computing, brain-computer interfaces. The pace of change isn't linear, it's exponential. Technologies build on technologies. Each breakthrough enables 10 more. Extrapolate that forward. Not 100 years, but 1,000, 10,000, a million. What does a civilization look like after 1,000,000 years of exponential technological growth? We have absolutely no idea. None. We can't even imagine the first 10,000 years with any confidence. 1,000,000 years is so far beyond our conceptual horizon that any attempt to describe it collapses into fantasy. But here's what we can say. They won't be using radio telescopes. They won't be building rockets. They won't be doing anything that looks like what we're doing, because they'll have moved so far beyond our current capabilities that our entire technological paradigm will seem to them like stone tools seem to us. Interesting historically, but irrelevant practically. Maybe they've uploaded themselves into synthetic substrates. Maybe they've re-engineered their own biology into forms we wouldn't recognize. Maybe they've discovered physics we don't understand and are manipulating reality in ways that are invisible to our instruments. Maybe they've left physical space entirely, existing in computational dimensions we can't access or detect. If this is what happens, if technological civilizations rapidly move beyond the detectability window into states of existence we can neither perceive nor comprehend, then the universe could be crowded with intelligence, and we'd never know. They're not hiding from us. We're just looking at the wrong layer of reality, with the wrong tools, asking the wrong questions. This is the transcension hypothesis, the idea that intelligence doesn't spread outward into space. It goes inward, into complexity, into efficiency, into realms of existence that are smaller, faster, denser, stranger than the physical universe we inhabit. And once that transition happens, which might happen quickly, maybe within centuries of developing advanced technology, those civilizations become ghosts, undetectable, untouchable, gone from our universe, while still existing in some deeper sense. If this is the pattern, if every technological species follows this path, then SETI is searching for something that only exists briefly. A narrow window between radio invention and transcension, maybe a few hundred years long, and the odds of catching anyone during that window are infinitesimal. The galaxy isn't empty. It's full of beings we'll never see, operating on principles we don't understand, existing in ways we can't detect. We're shouting into a crowded room, but everyone there is having conversations in dimensions we don't perceive, using languages we don't speak. And we're alone not because no one else exists, but because everyone else has moved on. There's one more explanation for the silence, and it's the darkest, the one that scientists rarely say out loud but increasingly whisper in private. Maybe intelligence is common. Maybe technological civilizations arise regularly. Maybe the filters behind us aren't that severe, and life finds a way more often than we think. But maybe there's a filter ahead, something waiting in the future of every technological species, a trap, a barrier, a great filter so lethal that no one gets through it. And the silence we hear is the silence of extinction, repeated across billions of worlds and billions of years. Nuclear weapons, climate collapse, artificial intelligence misalignment, engineered pandemics, nanotechnology accidents. The list of ways a technological civilization could destroy itself is long and growing. And many of these risks have a common feature. They emerge suddenly, they're difficult to control, and they're existentially dangerous. We invented nuclear weapons in 1945. Within 2 years, we had enough to end civilization. We've been living under that shadow for 80 years now, through accidents and close calls and geopolitical crises that came within minutes of triggering apocalypse. We're still here, but the weapons are still here too. More of them, more powerful, controlled by more nations, some of them unstable. This is the burden of the silence. It's also the opportunity, because we're not just observers in this cosmic story, we're the authors, the only ones writing, and the ending isn't determined yet. That's the choice. That's what the silence is telling us. Not that we're doomed, but that we're responsible, that no one is coming to save us or guide us or show us the way, that we're writing this story alone, and it can end in extinction or expansion, in darkness or light. The universe is waiting, not with judgment, it doesn't care, but with possibility, with the raw potential for consciousness to continue or cease, and that decision is ours. So we keep listening, we keep searching, not because we expect to find anyone, but because the search itself is an act of hope, a refusal to accept silence as final, a commitment to the idea that consciousness matters, that awareness is precious, that we owe it to ourselves and to the universe itself to continue asking questions, reaching out, trying to connect, even if no one answers, even if we remain alone forever. Because being alone doesn't make the questions less important, it makes them more important. The only questions anyone is asking, the only voice in the void. And as long as we're here, as long as we continue, the universe isn't empty. It's full of us, full of wonder and curiosity and the stubborn, beautiful refusal to accept meaninglessness. Subscribe.